All right, come on. Today we're doing consecutive integer problems again. We're just practicing one last time before we decide to move on, and because we're recording in our class today. Yeah. So today we're gonna do three problems together, and then I'm gonna give out your homework. Okay. So everybody turn to question number 6. Yeah. So you read the question. The product of two consecutive integers is 20. Find the integers. So two consecutive integers. Let's write out some let statements. What do you think the let statement should be if they are consecutive integers? Amazing, Cynthia. Great job. So x equals the first consecutive. Oh, boo. Okay, let me write them down, then I'll explain. So there we go. There we go. Those are our let statements. That's going to help us ultimately in figure out what numbers we need. So the product of these two integers is 20. What's that word product mean, Spencer? Multiplication. The product of the integers is 20. So the product of this integer, oh, boo. What is wrong with our computer today? The product of the integers, x times x plus 1, is, in math, is an equal sign, 20. Piece of cake. We know how to do stuff like that, right? Yeah. All right. So from here, what do we do? We're going to make it rain. We're going to distribute. We are going to distribute. So that's going to be x squared. Damn. Oh, boo. That is going to be x squared plus 1x equal to 20. Oh, come on. There we go. And then we're going to the first step, in solving these types of problems. Remember how I taught you to remember it? Yes, nice. Look at that. Maybe I can teach you math through weird sounds and you'll just remember it. Right? X squared plus 1x minus 20. No, I did not. But let's focus on this. Let us focus on this. Let's not talk about anything called the cinnamon challenge. Okay. What do? What's the next step in? Starts with an F. Factor. Do you know two numbers that multiply to be negative 20 but add to be 1? Yeah, but which one? Is it positive 5, negative 4? Yes. Or the other way around? Positive 5 and negative 4. It is positive 5 and negative 4. Yeah, we got to think of numbers that multiply to be negative 20 but add to be positive 1. So it's positive 5 and negative 4. Oh. There we go. Now we're going to solve it. Right? We're going to set both these things in parentheses equal to 0 and solve. All right? Subtract 5 from both sides. Boom. It is the same thing as the other one. But this solves the problem of me having to explain the homework again, right? We're doing a problem that just the wording was a little different, but otherwise it's almost exactly the same. Oh, you get it now, Bruna, huh? Kinda. Now, both those are our answers, right? Both those are our answers, right? That's it. We're done, right? No, of course not. Yeah. But here's the tricky part, right? Whoa. Does it say anything about it being positive? Does it say anything about it being negative? So do you reject any one of those numbers? No, which means there are two possible sets of answers, okay? Oh, I know, because let me take you back. This is from the same set of notes. Let me show you some, right? Let me scroll back, not to that one. Do you see in the directions, it says literally that it wants only the positive numbers? And that's why at the end of the day, I rejected the -8. But now let's go to the problem that we just solved, right? Go down to 6. Does it say anything about things being positive or negative? No, which means you don't reject either one of the numbers. Take that -5, plug it back in over here, right? Plug it back in. So one of the answers is definitely going to be -5. And what's -5 plus 1?
4.
Good. -4, right? That's one of the answers. That's one of them. Okay. Now let's take the other one. What about what happens when it's 4? What happens? What's 4 plus 1? 5. So you see, right? You see that there are two possible answers. Don't reject. Don't reject unless it says so. Juan, what's up, buddy? What's up? Because, it's a great question, Mom. Why can't it be 5 and -4? Because it says the product has to equal 20. What's 5 times -4? -20, right? So it's -5 and -4, because a negative times a negative is a positive. So just be... It is, but there's two ways you could get there. Confused? Confundido? Got it. Okay, let's go. All right, let's go on. We're going to do another one. Yeah, that's it. That's all the answer was 5 and -4. In fact, you could put your circle around it like this, or you could use the funny brackets like I showed you last time. Do you want to use the funny brackets, or are you okay like this? It's both of them. It's both of them. -5 and -4 is one possible answer. 5 and 4 is another possible answer. Okay. Let's go to 8. Let's go to 8. Uh-oh. Threw some extra words in there, man. Threw some extra words. Even. 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 How far apart are even numbers spaced? They are 2 units apart. Think about it. 2, and then the next even number is 4, and they are 2 spaces apart. How about like 10 and 12? 2. It never changes. Even and odd numbers are always 2 spaces apart. Consecutive, even, consecutive, odd. So that's the trick. That's the trick. When you try and set up your let statements, x equals the first consecutive even int. We're just going to use int for integer. And then the next one has got to be x plus 2. That's the trick to them. That's the second consecutive even integer. Okay, let's do this. What's that word product mean, Bruna? Bruna, what's the word product mean in math? It means to multiply. So the product of the 2 consecutive even integers is 48. So it's going to be x times x plus 2 equals 48. And then we're just going to solve it just like our other problem, right? We're going to multiply, we're going to distribute, we're going to set it equal to 0, we're going to factor, we're going to solve it. All right. Here it is, I've distributed the x's in, and now I'm going to set it equal to 0. So here it is, I've set it equal to 0. Now I'm just going to solve it up, right? We're going to factor that. Give me 2 numbers and multiply, it'd be -48. Add to be 2.
6.
Very nice, team. 8 and 6. X plus 8. Oh, come on, computer. Why are you so slow? There you go. There you go. We factored it. Now we're going to solve it. There we go. So there you go. There we solved it. We solved it up. Now, are we going to take both those answers? Yes or no? Are they even? Whoa! Just because something's negative doesn't mean it's not even. They're both even. To be an even number means you can be divided by 2. Can you divide -8 by 2? Then you're even. You are even. If you could split that stuff up evenly, you're even. Okay? So we got 2 answers. We got -8, we got 6. Let's plug them back in. So one of our answers is going to be, let's plug the -8 in. If I plug -8 in here, whoa, come on. If I plug -8 in here, then what's -8 plus 2? -6. That's one possible answer. And that makes sense because -8 times -6 is 48. And the other answer is just going to be 6, and 6 plus 2 is 8. And that's how we do it. That's how we roll. One more, and then we're done. All right. Last one. Find 3 consecutive positive integers such that the square of the third is 51 more than the sum of the first and the second. What? Nah, don't worry about it. Well, the first thing we're just going to do is find 3 consecutive positive integers. We're going to write our let statements. So there we go. We write out our let statements, x plus 1, and x plus 2. That's how it all begins. In fact, if you have no idea how to do these problems, but you write that stuff down, guess how many points you get? You get 1 point. If the problem is worth 4 points, you get 1 point for writing down let statements. Everybody can do that. That's why nobody should ever leave questions blank. You can do parts of these problems. Bless you. Now you do not have to take this down. I just want to help you out with something. Raise your hand here if when you read, a lot of the time, the words you read the words, you hear the sounds, but it flows right over you. I mean, you could read that same sentence 5 times, it's brand new on the 6th time. Yeah? This happens. We got to talk about that. We got to talk. You need to have a conversation with yourself while you read, like, how does this make sense? What are they talking about? Try and think of a picture, okay? My job here is I'm going to try and teach you how to translate math sentences into English. Anytime you see the word is, what is in a symbolic mathematical term? Angie, equal to. So where you see that is, that's the equal sign. Drop it down. There it is. The square of the third. Well, that's easy. That's just x plus 2 squared. The square of the third is 51. Is the equal sign. 51. What's the word more mean in math? Plus 51 more than the sum of the first and the second. Whoops. Piece of cake, piece of cake. Oh, that's just a lot of symbols. Let's try and simplify that down, right? And then I'll slow down a little bit. X plus 2 squared, that is just x plus 2 times x plus 2. And then I'm going to FOIL that out. Oh, come on, computer. Computadora. What's up? Thought it was Gertie. This is just 51 plus x plus. There we go. I'm going to FOIL this out. I'm just not going to use the computer because it takes too long. There you go. Now we're going to combine like terms. Now we're going to set equal to 0 and solve. We set it equal to 0. We got to think of some numbers that multiply to be -48 but add to be 2. It is. That's why I chose it, because it should be easy to figure out this step. Do you know 2 numbers that multiply to be negative? 8 and 6. Very nice. 8 and 6, -8 and 6, and there we go. We finished it off. Is that our answer, though? No. No, because in the directions, what does it ask for? Positive integers. It asks for positive integers. Let's highlight this up. It asked for positive integers. So look at our answers. Which one are we going to reject? Rejected. Rejected. Rejected, because it's not positive. Rejected. That means our answer is 6. Let's take 6. Let's plug it back in. So 6 is the first one. What's the next one? And what's the third one? And there is our answer. Whoa. That's it. That's it.